All right, today we're going to dive into a puzzle that completely messes with our intuition. It's a really simple question, but the answer is so wild it has massive consequences for everything from digital security to artificial intelligence. Let's get right into it.
So let me ask you something. In a room full of people, how many do you think it takes to get a 50-50 shot that at least two of them share a birthday? Now just think about that for a second. Your gut instinct might be, what, 183 people? Half the days in a year? That makes sense, right? But the real answer, it's way, way small.
Get this, it's only 23 people. Yeah, I know, that sounds completely wrong, which is exactly why it's called a paradox. But the math behind it is rock solid, and once you understand why it works, you unlock some incredibly important ideas.
So here's how we're going to break it down. First, we'll tackle the puzzle itself. Then, we'll uncover the secret behind the math, the power of pairs. From there, we'll see how this exact same idea shows up in cryptography and even creates some major problems for AI.
Okay, first things first. Why does that number, 23, feel so ridiculously small? Well, here's the trap our brains fall into. We tend to think about our own birthday and what the chances are that someone in the room matches us. But that's not the question, is it? The question is if any two people in the group have a match. And that one little change makes all the difference.
And just look at how fast that probability skyrockets. With just 23 people, boom, we're already over the 50% mark. Add a few more, get to 30 people, and the chance jumps to over 70%. And if you get 50 people into a room, there's a 97% chance of a match. At that point, it's pretty much a sure thing.
Okay, so what is the secret here? The key to really getting the birthday paradox is to stop counting the people and start counting the number of possible pairs between the people.
The best way to wrap your head around this is to think about handshakes, right? If everyone in a room shakes hands with every single other person, the total number of handshakes is the number of unique pairs. And every single one of those pairs is a new opportunity for a birthday match.
So let's just watch how this thing explodes. With 2 people, you've got 1 pair. Easy enough. But with just 10 people, that number jumps to 45 different pairs. And by the time you hit our magic number of 23 people, you have a staggering 253 unique pairs. That's 253 chances for a match to happen.
And this is the moment where a fun little party trick gets, well, really serious. The birthday problem isn't actually about birthdays at all. It's about a fundamental idea in computer science, the probability of a collision. A collision is just the technical term for any kind of match. The people are the inputs, and their birthdays are the outputs. The paradox just shows us that you don't need that many inputs before 2 of them create the exact same output. And this turns out to be a massive weakness in a lot of our digital systems.
So how does this little mathematical quirk become a powerful tool for hackers? Well, it all revolves around something called a hash function.
Basically, a hash function can take any piece of data, a password, a file, whatever, and it squishes it down into a short, unique string of characters. It's like a digital fingerprint. And the whole point, in theory, is that no 2 different files should ever produce the same fingerprint. But, in theory, well, that's where the birthday paradox comes knocking.
And this is the absolute kicker. A system might look super secure, with the number of possible outputs so large it's hard to even imagine. But because of the birthday paradox, a hacker doesn't need to try anywhere near all of them. To have a good chance of finding a collision, they only need to generate about the square root of the total possibilities. This is called a birthday attack, and it just craters the real-world security of these systems.
So what does this mean in the real world? Well, the consequences are huge. This principle puts a hard limit on how much data you can safely protect with a single encryption key. It's the reason cryptographers are always pushing for longer and longer keys, going from 128-bit to 256-bit encryption. They're trying to stay one step ahead of attacks that use this very fundamental weakness in the math.
But, this whole idea of finding unexpected collisions isn't just about hacking anymore. Its logic pops up in the world of big data and AI, where it can create what you might call ghosts in the data, patterns that look real and meaningful, but are actually just statistical noise.
This quote just nails it. What is rare for an individual is common in the collective. Basically, if you look at a big enough crowd or a big enough data set, weird coincidences aren't just possible, they're pretty much guaranteed to happen.
There's actually a name for this, the AI data dredging paradox. When you let an algorithm sift through these massive data sets, it is mathematically guaranteed to find strange connections. Like a link between people who eat a certain vegetable and their zip code. Most of the time, that's just a random collision, a meaningless coincidence created by the sheer number of pairs of data points. It's the birthday paradox, just on a terrifyingly massive scale.
And all of this leaves us with a really big, kind of scary question. As we start relying more and more on AI to find patterns in these huge oceans of data, the birthday paradox is a constant reminder that finding patterns is the easy part. The truly hard part is figuring out which ones are real and which are just the ghosts of a fundamental rule of statistics. Definitely something to think about.